Tamil Selvi, Department of Civil Engineering, Rohini College of Engineering and Technology Professor. GPS error choices. So error choices in the GPS in the world was like a laboratory with a perfect laboratory conditions. Basic GPS would be lot more accurate. Unfortunately, it is not so, and there's plenty of opportunities for a radio-based system that spans the entire planet to get fold up. Inaccuracies in GPS signals come from the variety of sources like satellite clocks, imperfect orbits, and especially from the signals stripped through the Earth's atmosphere. Since the inaccuracies are variable, it is hard to predict what they will be in order to correct for them. Although these errors are small, but to get and kind of accurate, some critical positioning jobs require all the errors, no matter how minor, are to be minimized. What is needed? A way to measure the actual errors as they happen. The error sources can be classified into three groups, namely satellite related errors, propagation medium related errors, and receiver related errors. These are all known as systematic errors. However, sometimes errors are introduced intentionally, known as selective availability. System error, satellite error. GPS satellites are equipped with very accurate atomic clocks, but as good as these clocks are, they are not perfect. Slight inaccuracies in their timekeeping ultimately lead to inaccuracies in our position measurement. The satellite position in space is also important, equally based. It is the starting point for all the GPS calculation. GPS satellites are placed into very high orbits and so are relatively free from the perturbing effect on the Earth upper atmosphere. But even so, they still drift slightly from their predicted orbits, contributing to the errors. Signal propagation error. GPS satellite transmit their timing information by radio, so that another source of error because radio signals in the Earth atmosphere do not behave as predictably designed. It is assumed that radio signals travel at the speed of light, which is simply a constant. However, the speed of light is not constant. It is only constant in vacuum. In the real world, slows down depending on what is traveling through. As GPS signals comes down through the charged particles in the ionosphere and then through the water vapor in the troposphere, it gets delayed a little since calculation of distance assumes a constant speed of light. This delay results into a miscalculation of the satellite distance, which is translates into an error in position. Receiver error. The receiver error also not perfect. They can introduce their own errors, which usually stem from their clocks or internal noise, multipath, and antenna phase center variation. Multipath. As the GPS signal arrives at the surface of Earth, it may get reflected by local obstruction and gets to the receiver antenna via more than one path. This form of error is called multipath error because in a sense the signal is getting to the antenna by multiple paths. First, the antenna receives the direct signal, it being the forecast, and then reflected signals arrive a little later. Antenna phase center offset and variation. The phase center of the antenna is point to which radio signal measurement is referred and generally is not identical with the geometric antenna center. This offsets to be elevation, the azimuth, and the intensity of satellite signals, and it's different for L1 and L2 ports. Also, true antenna phase center may be different from manufacturer indicated center. Then systematic effect can be eliminated by appropriate combination of the observables.